Hi guys, I'm so sorry I'm not there today, but hopefully this little video is going to help you through the lesson. And I know Mrs. Benson's going to do a great job helping you. Everybody turn and say, thank you, Mrs. Benson. Okay, for today's lesson, you are going to need a pencil and a highlighter. So let's pause the video and get that out, please. Okay, so today we are talking about LCM, which we know stands for least common multiple. The good news is it's a lot like GCF. In fact, we're going to use GCF to help us figure it out, but there's still an added step and a little bit more multiplying today. So let's talk about real quick what a multiple is. I put in the definition that to think skip counting. So we know multiples, you just maybe don't remember that that's what we call them. So you've been counting by twos your whole life, 2, 4, 6, 8, 10. Those are multiples. 3, 6, 9, 12, 15. Those are multiples of 3. So when you think of multiples, think many because it never ends. We could count by twos for the rest of our lives if we wanted to. So multiples many. So in the practice there, it asked you to list the first 5 multiples of 11 and the first 5 multiples of 24. I went ahead and put this up here just to show you the first 5 multiples of 11, 11, 22, 33, 44, 55. And that, of course, could keep going. And then the first 5 multiples of 24, 24, 48, 72, 96, 120. I just asked for the first 5 multiples, but we could keep going if we wanted to. So those are multiples, but we're trying to find the least common multiple. So the definition there is the smallest multiple that 2 or more numbers have in common. So I know this example is tiny, but make sure you look at your notes. The example is with the numbers 5 and 20. So if we kept counting by 5s and we kept counting by 20, what would be the smallest number that they finally have in common? So you can see the list there, 5, 10, 15, 20, 25, 30, and so on. And then the list of 20s, 20, 40, 60. Well, right away, we can see that the LCM, the smallest number they have in common is 20, right there in that list. Okay, so it says, why would we ever need to find the LCM? Again, it comes back to fractions. If we ever need common denominators, we look at those two denominators, 5 and 6, and we see, okay, what's the LCM? What's the smallest number? If I kept counting by 5s, kept counting by 6s, what would be a good common denominator here? And I hope your ears are perking up and thinking, oh, it would be 30, and then we would go from there. The other thing is, and this is what's going to apply to us, is when we are repeating events until they happen again at the same time. So this is going to be where word problems are going to come in next week, where you're repeating something every 5 minutes you do something and every 15 minutes you do something. When will you do it at the same time? Or you're getting paid every couple of weeks and someone else is getting paid every 3 weeks. When will you get paid at the same time? It just repeats over and over again. But we'll get to word problems next week. So how are we going to do this? Well, the directions again say to use prime factorization. So right away, the light bulb's going off that we're all going to use factor trees. So we're going to start off exactly the same way as we did GCF. So you should be doing this along with me. We're going to set up our factor tree for 16 and our factor tree for 20. And again, it doesn't matter how you set it up as long as we end up with the same prime factorization. So I'm just going to go ahead and do 2 and 8. And of course, 2 is prime. 8 can be broken down into 2 and 4. 2 is still prime. And we'll finish up with 2 more 2s. Okay. Over for the 20, I can break that up into 4 and 5. 5 is prime, and the 4 can be broken up into 2 2s. Okay. The next step is exactly the same as what we were doing with GCF. We are going to write the prime factorizations, but no exponents. So we're just going to write them in order from least to greatest using just those prime numbers. So 16, of course, is 2 times 2 times 2 times 2, and 20 is 2 times 2 times 5. So nothing has changed. The good news is it is still nothing has changed. So the next step is actually to find the GCF, believe it or not. So this is where you're going to need your highlighter. And we're going to find the matches. So in this case, we have a match of 2s and we have another match of 2s. And we're going to drop down those two numbers as part of finding our GCF. But this is where things change. Okay, so when we find LCM, in addition to finding the GCF, I like to call this everybody's invited to the party. So we've already brought these sets of 2s, but now we're going to include every other number that we see. So the ones that aren't highlighted. So I see another 2 here, so I'm going to bring it down. I see another 2 here, I'm going to bring it down. And I see another 5 here, I'm going to bring it down. And now it's one giant multiplication problem. That's how we find LCM. So this is where you're going to have to maybe do a few steps at a time. So I like to do my little carrots here. 2 times 2 is 4. 2 times 2 is 4. Bring down the 5. Now I'm going to do 4 times 4 is 16. Bring down the 5. And then 16 times 5. Anybody know? Is 80. The LCM is 80. Okay, so what we're saying there is if we were to count by 16s and count by 20s over and over and over again, the first time those would meet would be 80. Okay. All right. Let's try another one together. This one is finding the LCM of 18 and 108. And this is a good example where we're looking at some big numbers. So using the prime factorization is helpful because you might not know your multiples of 18 till we get to, past 108. So this is where prime factorization is a good tool to have. So we're going to start off with our trees. You can go ahead and start working on your tree. 18, I'm going to go ahead and do 3 and 6. 3, of course, is prime, and 6 we can break apart to be 2 and 3. Okay, 108 you might not know right off the bat. I do see that it ends in an even number, so that means it's divisible by 2. Or if you add 1 plus 0 plus 8, you get 9, so I could divide that by 3 if I wanted to. But I'm way better at 2, so I'm going to do 2. And it would be 54 on the other side. 54, I hope you know, is divisible by 9 and 6. And we can keep going on both of those branches to get 3 and 3 and 2 and 3. Okay, so the next step is to set up your prime factorizations. So 18 equals 2 times 3 times 3, and 108 equals 2 times 2 times 3 times 3 times 3. So we're going to continue just like it's GCF. Find the matches. So I have a set of 2s. I have a set of 3s. Remember, they don't have to line up and down. They can be diagonal. And I have another set of 3s. So my matches are currently 2, and I have a 3, and I have a 3. Now, remember, everybody's invited to the party for LCM. So whatever we didn't highlight, now we're going to add to that multiplication problem. So I have a 2 here. And I have a 3 here. So now we have one giant math problem. 2 times 3 times 2 times 3. So use your carrots again. Do 2 numbers at a time. 2 times 3 is 6. 3 times 2 is 6. Bring down that 3. 6 times 6 is 36. Bring down this 3. And then 36 times 3 is actually 108. So the LCM is 108. Okay, so if you were to count by 18s and count by 108s, eventually with the 18s, you would hit 108. And of course, the 108s, your very first number is 108. Okay. All right, one more example with me just to make sure we know what we're doing here. So 12 and 20. Set up your trees. So I've got a 3, a 2, and a 2. For 20, I'm going to break it apart to 4 and 5. And I'll end up with a 2, 2, and a 5. So my prime factorization for 12 is 2 times 2 times 3. And for 20 is 2 times 2 times 5. So let's find our matches. I have a match here. I have a match here. So I have a 2 times 2, and then everybody's invited to the party. So I've got a 3 and a 5 left over. One big math problem. So if I do my carrots, 2 times 2 is 4, 3 times 5 is 15, and my LCM is 4 times 15, 60. Okay, so if you were to count by 12s and count by 20s, the first number that they would both have in their list is 60. Okay, there are 4 on your own questions. Depending on the time, Mrs. Benson will assign maybe all 4, but if there's not a ton of time left, maybe just a couple of them. I'll leave that up to you, Mrs. Benson. And then if you want to pause this video, then I have the answers, and you can hit play for when everyone's ready to check their answers. And I'll just put them up here, and you can kind of go through them as you need to. Okay? Good job, guys.